Hello everyone, we will solve this today's LeetCode problem. This is crawler log folder. The question is the LeetCode file system keeps a logs each time some user performs a change. Folder operations. The operations are described below. That if double dot forward slash is given, move to the current folder. If you are already in the main folder, remains in the same folder. If dot slash is given, remain in the same folder. If x slash is given, move to the child folder named x. This folder is guaranteed to be always exist, right? So we have given three operations, and in three operations, what we need to do, that's the same thing which we have written. It just like we do in our uh, terminals, right? So you are given a list of strings logs, where log is the operation performed by the user at the ith step. The file system starts in the main folder, then the operations in logs are performed. Return the minimum number of operations needed to go back to the main folder after the change folder options. Okay. So basically the question is that we have given some logs, and we need to follow uh, this process, and we need to apply these operations on this main systems. And after doing all these operations, we need to tell that how many times how many minimum number of operations we need to do back to go back to the main folder after these all the operations which we have given in the logs, right. So if we see the first example here, if we see the first example mainly, so see, d1 is d1 slash, it means we need to go to the child d1. So we have moved till d1 in step 0. In step 1, again d2 slash, it means it will move to its child, this d1 child. So d1 child d2. Now it is moving dot dot slash. And what is dot dot slash? It means move to the parent folder of the current folder, and the current folder is d2 and its parent folder is d1. So we will move to the d1 in this operation. After d2 1, it will again make another child d2 1 to make and move to the d2 1. Now, when we do dot slash remains in the same folder, so we will don't disturb this, right? So basically, if you see, after this d2 1, how many number of operation do you think we need to apply to go to the main, right? And which operation we need to do? So if you observe here, dollar slash is only able to move to the parent folder, and nothing is able to move back, right? So we will use dollar slash only, right? So basically, how many times we need to apply dollar slash? That two times, one for d1, go to d1, then again for main. So we will apply two operations for dollar slash, and that is to our answer, right? So basically, if you observe here, that's a simple question. That if you observe here one thing, that dot slash dot slash has no contribution, right? No contribution. Second, x slash. So basically, we just need to find the count, right? We just need to find the count. So we will just count it, right? X slash has contribution. It will increase our count. It will increase our count. It will increase our count. So basically, when x slash is given, it means we need to move back for one count. Now when dot slash is given, I need to just decrease it, right? I need to decrease the count because it will move back to the parent folder. So I need to decrease the count, right? Because it will move back to the parent folder, and it will move forward to the child folder, and it has no contribution. So basically, we need to just count the operations, and we will do this, right? So what will happen if we are again what will happen in the case when we are in the main folder, already in the main folder, and we apply dot or slash? We will remain in the main folder because we can't go back to the main folder, right? move Moves back because it has no parents. So if there are multiple dot or slash and we are in the main folder, so we were not able to move. We were in the same main folder, right? So these three operations we just need to do, right? So basically, these three operations and you are good to go, right? So we will just apply this, and yeah, question, we will solve this question, right? So basically, logs dot size. Okay, or just we don't need this, right? We can simply write like this, logs, simple, right? And if this Si is equals to, so see, if Si is equals to if Si is equals to, if this Si is equals to dot slash, so what we need to do, we will just move increase our counter, right? So if Si is not equals to dot slash slash, sorry, not Si, S, if S is not equals to dot slash, and what, Si is not equals to dot slash, it means it must be have a x slash operation, right? So we will increase our counter simply. So we will increase our counter, we will increase our counter, right? And if both of this is not happening, so if now s is equals to dot slash, then we will decrease our counter, because dot slash has no contribution here, right? So it doesn't affect on our count, so we don't need to check that. If s is equals to dot slash, what I will do, I will decrease it. But what happen if, what will happen if in the condition, if there are many dot slash and we are in the main folder already, right? So it will decrease it, which is not correct. So count is should be zero, right? Count minimum is should be zero. So what we will do, we will just take max zero cnt minus one, we will write like this, right? Because count is main folder, we have started from main folder where count must be zero. We have started from count is equals to zero. So if we are in main folder, we should be, don't get less than zero, right? That's why we need to do this, right, before decrementing it. And now just we will return the count, right? How is this working? Let's see. See, first is d1 plus, so cnt plus plus count is 1, again d2 count is 2. Now when we add dot slash, we need to decrement it, so count will again 1. When we d2 1, count is again 2, right? When we add dot slash, it has no contribution and loop is over. So we will return the count 2, which is needed to two dot slash operations to move to the main operation, right? If we for this, see in the second example, if we see here, sorry, the third example, if we see here, when we go to d11, the count will increase to 1, right? When we do dot or slash, count will decrease to its main folder, so cnt will 0. Now again dot or slash operation is applied. So if we again apply dot or slash operation, it will be decreased if cnt minus minus will apply. So basically we can't move less than that, right? That's why I have applied cnt max 0 cnt minus 1. So this is how we will solve this problem. Let's just run it. uh Something, okay, right, yeah, let's submit it. Yeah, we have passed all the test cases. So what the time and the space complexity would be, time is O of n, of course, n is the uh, size of the vector of strings, right? And we are not taken any extra spaces, so space complexity would be O of 1, right? Okay, so this is the approach is good, right? This is O of n and this is O of 1. But there is one follow-up question that can come in interviews, right? Basic question, right? That, can you find the path, can you find the path of this logs or something, that how will you determine that, you how do you find the path? So we know the path of the logs, right? But how will you go trace back, right? At last, after these logs, when you move back to the main folders, which path, ultimately which final path is point, right? So for finding the path after all the logs, after all the operations, after all the operations, we can't do this in this, right? We can't do in this, because I don't know now that whether I have moved from d21 to d1 or d2 to d1 then main. I don't know, because this is just returning count. So for that I need to store the string anyhow, right? or you can store the indexes of logs, because that can give me the string, right? So basically in so for that, what we can do, we can use stack for that, we can use stack for that, right? Basically it can be a follow-up question by the interviewer, although it's a easy problem. So we can use a stack for that. What we will do, we will just do the same thing, that instead of this count, we will just take as a stack. Okay, sorry. We will, instead of this, we will just take a stack, right? This will be int to stored index, right? Because index is given, then you can find the string of logs from the logs, right? So what we will do, we will do the same thing. When we have x slash, we will push the index, that current index in my stack. And when we want to when we have dot slash, we will just pop out, right? We will just pop out, because that will be that will be but that should must be removed to the main folder, right? But with in this stack, without we will not pop out before checking that whether my stack is empty or not, right? If my stack is not empty, then I will do this operation, right? So we need to check this operation, right? And after that, st dot set. So we can do this, but what is the benefit of using this? So stack will, after this whole operation, logs operation, stack have the indices of all the children that can show our path of that how will I move from the child to main folder, right? It can show our path, right? So basically that's the main use of stack. Otherwise, if you just need to count it, you don't need to this stack, because it will take the extra space complexity of n, right? So that is not needed for just count. That is that is not needed for just for counting. But it is useful if the interviewer asks you about path and something, right? Or other things might be, right? So you need to use a stack, right? So basically that's the motto of this using stack. So yeah, that's all. Thank you so much. Bye bye.